Okay, so it looks like we got quite a few people in here. So I did the poll, and it looks like it's really pretty split. There's a couple more people that wanted to actually talk about creating tables. And so what we're going to do is we're actually going to do a little bit of both. So there's some people that want to talk about the lab specifically, and other people want to talk about creating tables. So we are going to attempt to do both at the same time, which I think actually will go pretty well. So I guess to get started, I just wanted to real quick go over some basic creating table stuff. Um, and some of this might be review for a lot of you, but just to kind of, I guess, show you a little bit about what each component does. And a lot of this might be reiteration from a previous video, but I wanted to go over what each component does, and additionally, how to troubleshoot. So as you're going through lab two, what can you do to find it? Because really, a lot of the question I've been seeing so far actually can be solved pretty easy with just one command. So I want to show you that one command and show you how it works. And I think the big thing is that once we get used to the way it works, it'll get a lot better as far as oh, I know what this does, so now I know what needs to happen, essentially. So real quick, what I'm going to do is I'm actually going to use part of Lab 2, since there was a big mix. Instead of using a different table, and we might come back to a different table at one point, but I'm going to actually use the lab tables. So I'm going to open up to Lab 2 here. And you'll notice that it's empty and it goes through a bunch of stuff. So real quick, I guess, just to, since we're here, what I'm going to do is I am actually going to do the first part of Lab 2 for you, which is when you actually copy the files. So if I pull up the instructions here, basically what I'm going to cover right now is just setting up the Lab 2 directory. And a lot of this stuff is like teaching. So like CD to there, well, I already did that by right-clicking in there and doing that. And so what this is going to do is it's going to copy all the files from the create script and the create directory in lib to lab 2. So you'll notice that as soon as I hit enter on that, all of a sudden we have a bunch more files here. Now what we're going to do now is we're going to copy, or we're going to move all the file names. So it says, we can make the change with this one. So basically what we're doing is we're renaming create Oracle store 2.sql to apply Oracle store 2.sql. And you can do this if you want. I'm actually going to skip this step because what I actually like to do is I like to actually just copy them one by one. So like if I open up my apply Oracle lab2.sql, oh, and it's trying to open it in MySQL Workbench, which I don't want. So we are going to say properties, file options, general.sql, and we want to open it with kwrite. Okay, so I'm going to open up this. So if we open this up, you'll notice that there's already some stuff in here, which is really pretty nice. Okay, so it's got a bunch of stuff in here. You can copy the other one. You can do it this way, either or. In fact, let's just do this. There we go. So now we have apply Oracle 2.sql. Should be pretty similar. Okay. So now what we're going to do is we are going to adjust some of this stuff as we go. So what I like to do is I actually like to comment out everything except for the log file stuff, obviously. And how do we mass comment? Somewhere here, there's a way to comment all this out, and if you know, let me know. Toggle comment right there. I thought that's what I was doing, but maybe I was wrong. Anyways, so we toggle comment. What that does is it means that we're only going to run the one script. So I'm going to set this to _lab. Oh, and one step that we need to do is we need to rename all of our files because we want them to be _lab, not the other way around. So what we're going to do is we are going to create a script. So inside my terminal here, what I'm going to do, well, that's the wrong terminal. Inside this terminal, I'm going to do touch rename.sh nano rename.sh, paste in that code that's on his website, save it, exit, and you can do that with an actual editor. It's just way easier to do it this way. chmod 777, and this is in the instructions, so don't worry about it too much. All right, so now we have this rename.sh file, and we are going to run that by typing /rename.sh, and what that does is it changed all of our table names to be table_lab.sql, which is really nice. So now I closed that window. So we're going to open up a new terminal here. Okay, so now we're actually in the lab because we have all of our files ready. And basically what these files are, and a lot of students get confused with this, they get frustrated working with someone else's code. And if you are like that, don't use someone else's code. You don't have to copy all these files. You can create them yourselves. In fact, sometimes I think that way is a little bit better. I'm gonna use it because basically what we're doing is the tables are the exact same. All we're doing is we're renaming some of the names of tables, columns, sequences. Basically, we want to make like a working duplicate of what's already there. So the first thing we want to work on is system_user_lab.sql, and the website really takes you step by step through this first one, and that's so you can kind of go through it all the way through again. So if you're looking for that, I believe it's in the helps description, maybe it's in the instructions. Let's see. Setting up the Lab2 directory. Yes. All right, here. So the tutorial for editing a table creation script. So this will walk you through, and it does system user lab, but the process is almost the exact same for all the other tables. The only difference is name. So just know that as I go through this, I'm going to be following this tutorial right here pretty much the whole time. And then, but I'll be adding a little bit to it here and there. All right, so let's get started. So I'm going to open up System User Lab because essentially what we're going to have is we're going to have this master script. So apply Oracle Lab2.sql is the master, right? It's going to call a bunch of these subscripts because we're going to have a script that creates each table, and this master script is going to call each one of those. So we have apply Oracle Lab2.sql, that's the master, and all of our other ones. So this week for Lab 2 and actually Lab 3 and 4, you are actually going to submit all your .sql files, all your .txt files, not just the master, because it's not going to show us much besides the fact that, oh, you're calling some other ones, but we want to see what the other ones are actually doing. So I'm going to sneak that in there that you need to submit all your .sql files. So I'm going to open up system_user_lab.sql because this is where we're going to start actually working. The first thing I want to do is change our spool file, our log file. Just put _lab there. And what that does is because someone else said, oh, there's a bunch of these txt files. Yeah, we're creating our log files in the directory that we're running from. So when you run systemuserlab.sql, it generates a file called systemuserlab.txt because of this command right here. And then at the very bottom, we close that file, or else otherwise it keeps spewing to it, right? So anyways, we can ignore a lot of the stuff in here, and that's kind of really nice, but I'm going to kind of explain a little bit to you what it does to be able to kind of, I guess, help you navigate just a little bit. So set echo on is a command that all it does is it's saying that it's going to print everything to the console. Set echo, set feedback, set null.
Sorry, I have a question.
Yeah.
So about this pool part right there, do we need to change all the SQL file and put underline lab.txt, because that doesn't say in the lab? Does
Yeah,
that
you
make
don't.
sense?
Yeah, you don't have to.
Okay.
It's just so they don't. The normal ones don't get overwrote by the ones that we're gonna do. But
Okay. Perfect. Thank you.
yep, not required. So, anyways, a lot of this stuff is just to set kind of like the terminal view for us. Like we're basically saying, look, print everything to us. If it's null, print the null out in the 2 carets. And then page size is 999, which means that's the size of our page. I'm not quite sure why 999. I don't ever really mess around with that variable, so I'm not too sure. Server output on size unlimited, that says, look, kick everything back out to us. So we don't need to worry too much about this. Just know that it's there for a reason. Okay, so this stuff is out of the scope of the class, but it saves you guys a ton of work. Okay, because as I've said before, learning databases is almost a catch-22 because you have to start somewhere, but to start somewhere, it kind of goes full circle, meaning that you have to understand other things. And so at some point, you just got to dive in and start going in. So anyways, this is an attempt to actually slim down on some of the work you have to do. Unfortunately, it's like looking into the hood of a car. Even though, all I have to do is focus on the radiator, the rest of that car there is still a little confusing, right? So that's what I'm going to try and do, is show you all these different components. And even though you don't need to necessarily know what they do at a deep level, just kind of know like, okay, this is what this chunk does for me in this process. So that way it's not as confusing. Because if you can see the radiator and know, I need to focus on the radiator, but you know where the hose that's connected to the water pump, you don't need to worry about the water pump, even though it's connected, right? So we just need to know where we need to start looking, what we're going to focus on, and knowing what the water pump does is good, but we don't need to know how it works at a deep level. So keep that in mind. I'm going to talk about this stuff, but I will let you know. I will try to let you know, if I can remember, where kind of the scope of this lab is right now, okay? So anyways, what this first little chunk here does is we create a variable. And this is more for database 325, actually, is when you'll start messing a lot with this kind of stuff. But we create a variable to store the table name. And we do this so you don't have to type, copy, paste names quite as much, which is good. And it's really pretty clever. When you get into 325, you'll cover it a lot more. But for right now, just know that all we're doing is we're saying, look, make a variable called table name and have it equal to the uppercase string here, which is system user. So essentially, table name is system user, all caps. So what we want to do, though, is we want to change that to system user lab. So you will want to change it here, but this changes it essentially in a lot of other places. So system user lab. Okay, and it verifies it. It tells you the name. That's what this does, is it says select system user lab from dual, and all that's going to do, and if you want to try it out, always feel free, right? So if I do select, and we know that table name is system user lab, all caps, You just put that in there. I can show you what this does. Oh, and I'm not in SQL Plus. Let's try getting in SQL Plus first. So when we select from dual, we're pretty much selecting from nothing. And you'll notice that it has System User Lab. So that's all it's going to do is just print that out, just like we did just right there. So now this next part is where a lot of people get a little confused. But the nice thing is we don't have to touch any of it anymore. You used to actually have to do this. But just know that what this is doing is it's going through and it's actually dropping the table and the sequence. Okay, and we'll talk about what a sequence is in here in just a minute. But it's dropping the table for you because unlike a lot of things, like if we create like a variable or, you know, unlike a lot of other probably languages, code you've written where you can just create like something and just rerun it and it just keeps going. Databases are meant to be very permanent, right? You wouldn't want someone to rerun this script on accident, like accidentally do a create table and lose all the data, right? So what the way it works is once a table's created, it is there. And if I try to create a table with the same name, it will throw an error. It will say that table's already created. And so what we do is we make our scripts so we can constantly rerun them. That way, as we're troubleshooting, if I want to change something, I can change it, run it, and it won't have any errors. It'll just delete the table, recreate it, and then we're actually going to repopulate it, which when you're developing is fine. In production, that never happens, FYI, because you're talking about a lot of data. You know, Facebook isn't going to say, oh, you know, we want to rename that column. So let's drop the table and all hundreds of millions of rows of data in there and just recreate it and refill it. No, that would be bad. So just know that this is kind of a development process. And a lot of this is just because we're in a class where, you know, you're practicing, you're learning. And so we want it to be able to rerun. So anyways, this step right here is it deletes the table. So that way, when it hits this piece of code, it can create it again. So let's talk about the important. Yeah.
I noticed that and I haven't gone through all of it yet, but I noticed there was a delete thing and a drop thing. Is there a difference, or is that just semantics, or is there a big difference?
Yeah, great question. So, and you'll see this a lot when we get into like finals and stuff, and even as we start getting more into like, you'll start hearing about it in this week. Actually, in fact, some of your reading was about DDL commands. And I guess that's the best way to describe the difference. So there's DDL and then there's DML. DDL stands for Data Definition Language, and basically what that means. Well, and let me talk about DML. So there's Data Definition Language, then there's Data Manipulation Language. And the way that I always did this, because, you know, in your cert tests and even in this class, you'll have some questions on the final about DDL versus DML. The way that you can always think about it is, okay, does this affect the table or the structure? And when I talk about the structure, like think about a house, you know, does this affect the house or does it affect the furniture and everything inside of it, the contents of the home? I sound like an insurance person. But anyways, you have your DDL is the structure. It's the house. And then your DML is the contents, the data inside. So when we talk about drop versus delete, a drop statement drops the whole physical structure. And along with dropping the physical structure, you delete everything inside of it, right? So, but that one's a DDL statement because you're affecting the structure of the table. Now, a delete statement deletes data from within that structure, but the structure remains intact. I mean, in fact, you can delete some rows, but not all rows from a table. So when you see a delete, know that we're deleting records. And when you see a drop, we are deleting the whole table or dropping the table. Basically, the table goes.
Or the rows or columns. Like on a spreadsheet, you can delete the column, or you can just delete all the contents out of the column.
Well, and it's a little bit.
Is it bigger than that?
Yeah. So think about it like this: a drop statement obliterates the house off the face of the earth.
So the whole thing, not just the column.
Yep.
Everything.
But a delete statement deletes everything inside the house.
Okay.
If that makes sense.
Yep.
But the house is still there. So yep, great question.
Okay.
And that DDL, DML, we'll come across more and more statements all the time that you'll start to notice the trend because they fit in there. And there's one other little category, but we're not going to talk about that right now. Okay, so let's get into the meat of this thing, which is actually creating a table. So this is actually where we get to start to create our house. So the table is just the structure, right? We're not going to put any data in there right now. This is just the physical structure that's going to hold our data. And what makes database systems so good is the fact that we can really, tighten down the reins on how we want to put data in there to make sure that our data is really accurate, really clean. And that's what constraints are for. So we're going to talk about that. So the first part of a create table statement is obviously we say create table and then the name of the table. So naturally, as we are wanting to do this, for example, if I just take and copy this, and just know you can always do this. If I want to take and copy this in here and hit run, you'll notice that it says, oh, the name is already used by an existing object. Well, that's because we already have a system user table, right? So we want to rename this to be system user lab. And I'm not going to say underscore a lot, so just know that it's implied, right? So system user lab. So now all of a sudden we have a table called system user lab. Now within that table we have columns, and think of your spreadsheet. Up at the top are our column names, where each little chunk of data goes for each row. So the first one is system user ID. Now this is the primary key, and anytime, well, not every time, but I'm going to say effectively all the time, whenever you create a table, the person building the table always puts the primary key first. It's just good practice. Everyone does it. And what I mean by primary key is it is the thing that is unique to every row, right? So believe it or not, because, everyone has student numbers, right? Well, believe it or not, student numbers are usually not the primary key of like a table that houses all of our data. There's usually a more arbitrary number than that, and that's this primary key. So for example, you'll notice here that we have like our system user ID, which is our primary key, and we have a name, group ID, user type, first name, middle name, last name. There's lots of data in here. Basically, the primary key is going to become an arbitrary number that we really don't ever care about for the most part. I mean, we very much care about what it does, but as far as like reporting, like the actual data that means something to us itself, it means nothing to us. And it should be that way. And a lot of people, when they design databases, they think, oh, like a student number, let's just make the student number the key of the database. And that's bad because sometimes people change student numbers. And what's really important to note here is that the primary key is what will connect your data to all the other tables. So it's really important that number will never change. Period. If that number ever might change, you might be designing your database wrong. So we create a system user ID called number. Well, good practice with primary keys is to always have it be the name of the database. I mean, and there's a lot of different practices out here. In MySQL, the big thing is just to call ID and not have a name. But in week 5, I'll show you why that gets confusing. So what's really nice is we always create the column called the name of the table with ID somewhere in there, kind of to infer that, look, this is the ID column of the table. So that way, if you see the column, you know immediately what it's for. So in this lab, any ID key that's any primary or foreign key, let me rephrase, scratch what I just said before, any primary and foreign key column we change. And I'm going to show you how to identify those. So just know, and then pretty soon you'll just know. You'll see it and you'll be like, that's primary key, that's foreign key, that's primary key, that's foreign key, and we'll move on. So right now, just know that this is the primary key. Okay, and it's a number data type because that's usually what's used, numbers. Now, all these other stuff, and by the way, if you want to know what to change, if you actually go down to like each of the points, it tells you exactly what the table should look like. So I know to put underscore lab in there because it says to right here. So you know, just know that if you're ever confused, just come here and look, because there's this nice little table here that shows you everything about it, and I'll show you how to read this because it might look a little confusing at first. Okay, so we do that. Now you'll also notice that we don't change any of these other, even though this one has underscore ID in it, we don't change it, and the reason being is because it's not, even though it's kind of a foreign key, we'll talk about it. It's not a primary key for another table, essentially. So we're only going to rename the primary keys for these tables or other tables. So we go here. So we have the column name and then the data type. Now you'll notice on this one, like system user name, the data type is a varchar2, which means that it's a string. It's just a string of characters. So that could be Billy245 or whatever. And then in parentheses, it has the number 20. This means that there can be 20 characters in that string, no more. There can be less, but no more than 20. And the reason why we put this limit on there, because a lot of people think, well, why would you want to limit it? Well, when you're Facebook and you have hundreds of millions of rows of data, that can take up a lot of storage because you're basically allocating the memory here. So even though we're not using all 20, it's there for us to use. So you can see how you want to be able to say, look, I want to be able to give them everything they need, but just enough, right? And that's kind of the big game that you play when you're designing databases. You have to think about everything and really kind of anticipate how the data is going to be used all the way through the process. So that's the data type. Now, the next piece is called an inline constraint. Okay, so a constraint is a way that we restrict what goes on in our table. So an inline constraint is in line with the column name, just like this, right? An out of line constraint is not out of line with the column name. So inline constraint, out of line constraint. So the constraint in this case, this inline constraint, is we say, look, we're creating a constraint and we're going to give this constraint a name. And we want to change all of these constraint names because it can be really helpful to know what they are. Because if we ever violate this, if we ever break this constraint, it will say, whoa, you can't do that because you have broken constraint NN system user lab 1. And so then immediately we can say, oh, system user lab 1, and we can go in here and look, or sometimes we just know, like, oh, that's the username. And then you know where to look to see what's going on. And then the real important part is, what does this constraint do? And in this case, it is a not null constraint. And null means empty. So this is saying that, look, system username can't be empty. And I know we've all done those. We've all done those forms online where it says, like, you know, this is a required field and you can't hit next. Like, you're trying to get some free software, right? And they're like, oh, we want your email. And you're like, okay, no, thank you, because I know you're going to spam me. So you try to skip it, but it won't let you. And then you end up using like a trash email that we know we all have. That's because they enforce a not null constraint on their database, right? So not null. So just real quick to kind of speed up a little bit because we're not moving very fast, which is fine. We have some more column names here and some different data types. So we've got another number, some more varchars, and then we have a date, and a date is a date. So nothing too confusing there. Just know that it is only a date and not a timestamp. Okay. Now, before I move on, I'm just going to real quick and rename all my constraints here since we already talked about it. Okay, so I usually just copy and paste these ones right in there just like that. Okay, so now we get down here to the out-of-line constraints, and this is where we really kind of finish off the design of our table. So we say constraint, and then we have our name. So in this case, PK system user 1. Now, the way they name this is so you can immediately know what this is for. So in this case, PK stands for primary key. And what we're doing here is we're telling the table, look, this ID column, we want this to be the primary key of this table. And so just like the other constraint names, we're going to add _lab to it. Then it says with the type of constraint it is, primary key, and then for a primary key, it has in parentheses the name of the column that's the primary key. Now, we renamed this column, right? And so it's going to say, oh, I want to make system user ID the primary key. But it's going to look through here and say, whoa, there isn't a column called system user ID. That's because we renamed it. So we're going to change that to system user lab ID. Okay. Now this is where, so that's the primary key, right? So the primary key is now finished. The next two constraints are called foreign keys, and this is how we connect our table to another table. What's tricky about system user table, or in this case system user lab, is we're actually connecting it to itself. And some of you might think, well, what's the point of that? Well, in every table we have in this database, we have what's called, what I like to call our who audit columns. And who audit spelt like who audit, right? Because it tells us who did what and when, right? So this is really important because it's super helpful. What this does is it tells us who created the row in our table, who last updated the row in our table, and when for both of those things. Now, our system user table tells us who can use our system. So in this case, system user is going to have everybody that is interacting with our system. So anyone we'd want to track, right? So that's why we're connecting it to ourselves, because we want to say, okay, let's say that I get hired on somewhere, and so the boss makes me an account. My record will show that my account was created by the boss on X date, right? But let's say that you're working there and you notice that there's a name in there that you've never seen. So you tell your boss. Well, he goes in and looks, and it's the friend of somebody who worked at the movie store, and he's getting free movies because let's say employees get to rent so many movies for free. Well, you go in there and look, and sure enough, Joey, the other kid who works at the movie store, created that because you would actually be able to see it because of these columns. Okay, so that's why it's there, and it's connected to system user lab. So that way, it's all connected. And what the foreign key does is it says, look, you can't create a row in this table unless the created by column already exists as a system user. So that's essentially what we're doing. So the first thing we do is change the name, like all the other constraints. And this time it says foreign key, and this in parentheses is the column here locally that we assign that foreign key to. So created by is now going to be connected to a foreign key. And then we say, where does that point to? And we say this references system user ID. Now, what's tricky is that as this is written right now, this would work. Because we do have a system user table, and it does have a column called system user ID. So a lot of people miss these because there is no errors. It works fine. And yeah, it is fine, except for you're connected to the wrong table, right? We're connected to the other one. And we don't want that. So what we do is we change the table name, right? The table name is what comes before, and then in parentheses is the column name within that table. And we know that we changed it right up here, and we want to reference this table that we're creating. So we add _lab there. Okay, and we're going to do the same thing for the other one, because one is who created it and the other one's who last updated it. Basically the same thing, but tells us who created it, then who last updated it. Okay, any questions up to that point? Real quick, I guess, before I go on, I just wanted to show you that if you don't know, you know, how that works, because maybe you don't know, like, oh, do I change that or not? You can look here and say, oh, the created by is a foreign key to system user lab. So that's the table name. And then so we know that the reference column goes in parentheses, system user lab ID. Okay. Now I like to show you how it all works. So that way, instead of just trying to like read the table on the website, you can actually just kind of infer it from understanding the logic of what we're trying to do here. So anyways, does anyone have any questions up to this point? Create table. Primary key, foreign key. Is there anyone who does not understand what a primary key and a foreign key do? It's real quiet. So I'm going to assume everyone knows. I guess just to reiterate. Okay, so someone asked, is there a copy paste shortcut in SQL? Are you talking about the terminal? Like in here? Because in KWrite, you can just use Control-C, Control-V like normal. In a Linux terminal, you have to use Control-Shift-V. Or you can come up here and do edit paste, and it'll tell you the shortcuts. So you Control-Shift-V. Good question. Okay, so that's how we create our table, right? And if you want to, you can actually just, like me, when I'm testing my code, I just pump it in here, right? It's not going to break anything. Boom, table created. And then if you want to just double check, just because you're not sure, we can go, you know, look into System User Lab here. DESC, describe the table name, and then we can actually see our table here, which this command will come in handy a lot. In fact, I'm going to show you a lot of different ways right here in a few minutes on how we're going to do that. So now this is a validation query, okay? And these are in there so we can know if we did things correct, so you can know if it's done correctly. So I'm going to copy paste that in there. Oh, and I don't have a bind name. So that variable name's in there. Now I'm going to do this just for right now. Not recommended you do, but I'm going to just put that in there and just test this just to make sure. More just to show you what it's going to look like. And so boom, there we go. We can see our table name, the column number, the column name, is it nullable or not, and then the data type. Same thing that the other one showed us pretty much, just a little different. So I'm going to change this back now to table name. All right. Now most of this should be good. Now, on some of the other ones, you will have to do a little bit more. So, but this one, once you finish that first table, you're done. Now, the reason why this one has so little and others have more is because this is actually, believe it or not, the parent table of pretty much everything. It has no dependence except for itself, and that's because of this foreign key that references itself.
Brother Crook?
Yeah.
Isn't there another line at the bottom that we need to change on this one too?
Let me see.
I think the create sequence.
Oh, yep. Right here.
And the unique, yeah.
Yep. Nice catch. So, yeah, I almost missed those. So, the index, a unique index is a way that we tell rows to be unique, right? So for example, I'm sure that we've all, let's use Gmail, for example, because pretty much everybody has a Gmail. When you go to sign up for a Gmail, it says, oh, you can't use that email because it's already in use, right? Well, that's probably because Google put a unique index on the email address field. And why would they do that? Well, because they only want one person to have that email address. Just like in this case, we're going to put a unique index on system username because we only want one person to have that username. Otherwise, what would be the point of logging in, right? You know, if two people can have the same username, you're going to rely on the password to be the same? No. So we make sure that the username can't be the same. Now, those of you who are probably like coders, you know, web developers and stuff are thinking, well, we could do this in the web, you know, like PHP, Python, whatever. You could, but A, it'd be a lot less efficient because the database is built to do this kind of thing. And C, that leaves room for error, right? Because technically the idea is that you might want to do both, or you just let the database handle it and then you capture the error and send it back or whatever. So anyways, we create a unique index on system user. Now we want to change the name of this index because indexes can't be the same name. Oops. So we're going to put underscore lab there because that's the index name. Unique system user lab 1. And then here we want to say what table we're putting this on, which is system user lab. And then in parentheses, the name of the column. Now, let's say I'm confused. Oh, do I need to change this column name? We're all going to think it. If you're ever confused, just do a describe on the table. We're applying it to system user lab, so we do a describe, and we're putting it on the username, system username. That's how it's spelled, so boom. We leave it just like that. Okay, so now system usernames have to be unique, right? There can only be one.
There's no difference if you have a space or not between the parentheses there, before the parentheses?
No, it doesn't matter in this case. So I'm going to leave no space and an index created. Otherwise, it still works. So, yep, should be fine either way. And then down here, so we're going to talk about a sequence. So we talked about a primary key and how it has to be unique for every row. And most of the times, our primary keys are numbers that start with 1 and go up till wherever, right? And we can start wherever. And in this case, we're going to start with 1001. So in Oracle, our primary key does not auto increment, meaning that it's not magically going to maintain those for us. Oracle's a little bit more hands-on, a little bit more powerful though. So what we're going to do is we're going to create our sequence that's going to manage our primary key for us. And when I say manage our primary key, it's going to keep track of where we're at on our primary key. But there's a lot of benefits to this, which you'll see in weeks 3 and 4. So anyways, a sequence is just a sequence of numbers, and it's going to keep track of it. So real quick in the terminal, I just want to show you what this does. So if I create a sequence, and let's just call it test, right? And I'm going to say start with 1. Okay, so I just created my sequence. Now what I'm going to do is I'm going to see where that's at. So if I select curval from test, or sorry, if I select test.curval from dual, I get an invalid identifier because, believe it or not, this actually doesn't work until after we get there. Okay, so, and actually I think it's because I didn't put 2 R's. Is it 2 R's? There we go. So you'll notice that it says sequence number not allowed here. And the real error is because we haven't actually got a number yet, because I'm trying to get the current value, which doesn't exist, because if I do this, select test.nextVal from dual. Whoops. Let's see. Let's try this. There we go. So if we select the next val, you'll notice that it starts from 1, even though we did next val, because the number doesn't exist until we run next val once. So now I can run curval, and it's 1. Apparently there's a lot of updates. But now if I run next val over and over and over again, simulating a lot of inserts, you know, you'll notice that it just keeps on counting. Okay, so that's basically how it's going to work. And essentially, like, let's say Facebook uses Oracle, if they do. They may or may not use Oracle.
So this 1001 is just an arbitrary number they chose. Instead of starting with 1, they wanted to start with 1001 and so forth.
Yep, and a lot of people do that because
no reason behind the 1000.
No reason behind that, just besides the fact I know a lot of people start at 1001, so that way there's not like smaller numbers. I'm not sure why. It really doesn't. Yeah, it really doesn't matter. I know the reason they chose 1001 for this class is actually because there was some cheating going on, so they changed the sequence number so that they could identify work that had been copied, essentially. So I'm going to drop the sequence, and I'm going to create the sequence again. And this time I'm going to say start with 1001. So now if I do my curval, you'll notice it says it's not yet defined in this session. That's because we haven't run this. But once I do that, then I can run curval. And you'll notice that it does the same thing. It just starts and builds. So yeah, so they're pretty simple. You know, they're just basically glorified counters, essentially. And they have 2 functions. One is get the next value that's available, or B, tell me what the current value is. I'm going to drop this before I forget. So we're going to create our sequence, and we give it a name, and we want to rename this with _lab. And it starts with 1001. Don't worry about the no cache right now. It's just not going to cache stuff. Okay. And then we get down here and it does more validation queries to make sure it's accurate. And then finally, it closes the log file. And that is the system user lab file. You want to save that. And now we're going to go back to our home base, apply Oracle Lab 2. And, you know, because I uncommented a lot of this stuff out, right? But what I'm going to do is I'm actually going to uncomment this big query here. Okay. But what I'm going to do is I'm going to go to his website and clear down here at the bottom. It says confirmation details for tables. I'm going to take this and I am going to copy this new one down here. And I'm going to paste it over top of this one. The main reason being is because I'm too lazy to type _lab on all those when it already exists. So then I'm going to save it, right? And because we still have all this commented out, the only one that's going to run is this _lab system user one. So let me get to where the lab actually, oh, I'm already there. So let's just read up this one. And we're going to run the parent one, apply Oracle Lab2.sql. And right now we only get one because that's the only one we finished, right? System user lab. So as we build more, as we finish more of these files, more will show up there. So let's take a look at the next one. Should be member. Well, is it member? Common lookup. Let's look. It is member. So what time is it? It's 5:30. So real quick, what I'm going to do is I'm going to run through member super fast. Super fast. So,
I have a question on that one.
okay.
A problem on the bottom part of this one.
Okay, yeah, let me run through this one. And then when we get to the bottom, or you just stop me when I'm getting close to where your error is.
Sure.
Make sure I got them all.
Yeah, it's that part right there.
This one?
Okay, you just answered that. So
Okay.
I forgot the member. I think I forgot this last lab bit right there.
Yeah, that one's tricky because you'll notice that if it's like this, it actually syntax highlights it for some reason. And so those ones kind of like mess with the brain a little.
Probably because of that one.
Yeah. Yep. Okay, so that one's pretty easy too. Basically what I'm trying to do is I'm trying to get you to common lookup, wherever that one is. Okay, I actually missed common lookup, so we should have common lookup next. So yeah, common lookup. And the reason I want to talk about this one is the common lookup table is fundamental to understanding database design because it's kind of like a hub, and it's a really clever idea. And I'm not sure who originally came up with it, but we'll talk about it because I'm sure it kind of just came out of necessity, right? So anyways, I'm going to do this one a little bit faster, just like we did before, just because we talked a lot really in depth about the other one until we get to where I want to stop. So once again, I'm just going to rename all these constraint names. I already renamed my primary key. This one doesn't have any foreign keys that are primary keys. So I don't change any of the column names, but it does have foreign keys to the who audit columns, but we don't rename those. So, and I need to change my primary key. The foreign keys, got the two tables, got their columns. Okay. So let's go down here. We're going to create an, and you'll notice that this one's a non-unique index. And a non-unique index is just like the other one, except for before we said like, oh, it's a unique index, meaning that it can't have duplicates. Well, what we're doing here is we're saying, look, it can be a duplicate, but what we're saying is that it's one I'm going to query a lot. And we're basically telling the computer that it's really it's used a lot. So make sure you keep track of this one because it'll make it faster. So basically what we're doing, we're saying, look, this one's going to be used all the time, so make it fast, right? So we create an index on there, and we change the index name, the table name, and then if the column name changed, we changed it. We just want to make sure that it matches. And then same here, except for this one is the unique one. Now, this one's a little different because you'll notice that there's two column names in here. And yeah, we can do that. So basically, the combination of these two columns have to be unique. So before we just had username, right? Well, let's say that we wanted, let's say that it was only possible. Let's put it this way. You know, you're in school. Could you take CIT225 twice in the same semester, in the same term? No, right? Why would you? So if we were designing a database table for BYU Idaho and their student information system, we would probably build a unique index on the roster, right? Or the table that tells us what classes students are taking. And we would say, look, create a unique index on the person ID or the student ID, whatever, you know, the student ID, the course ID, and the term ID, right? Because effectively what we're doing is we're saying, look, if you create a unique index on the person, the course, and the term, effectively we're saying that a person can only take a course in a term, only one. You can't take the same course twice in a term, which makes sense. And that's effectively what we're doing here, but we're only doing it with two. So what we're doing is we're saying common lookup context and common lookup type. The combination of those two have to be unique. So I can't have a common lookup context of member and a common lookup type of group twice. You know, they can be different combinations, but the combination cannot exist twice. So that is a unique index with two columns. Okay, so up there, you know, so far we've been building the table, and that's pretty much the end of it, you know, besides building a couple indexes and stuff. But what we're going to do here is we're actually going to add a constraint after the fact, okay? So just like I talked about before, we have a DDL statement because we're dealing with the structure of the table. And it says alter table. And then that's how you know, right? Because we're altering the structure. We're altering the table. And we want to change the system user lab table. And what are we doing? We're adding a constraint, and we're calling it FK system user lab 3. And it's a foreign key for the system user group ID column. And it references common lookup lab and the common lookup lab ID column. All right. Now, this one's kind of weird because we're in the common lookup lab file. Why is there something for system user lab here? Well, the reason being is because system user lab needs to reference common lookup, but it was never, we couldn't put it in the system user lab file because common lookup didn't exist at the time. So it's like a big circle. Now, what's interesting is now that we have this two-way connection, one, they're dependent on each other, right? So common lookup, because of our foreign key constraint here, is dependent on system user lab. now that we added this, system user lab is dependent upon common lookup lab. So we've basically tied these tables together by two strings, right? They are tied together. And we're going to do it again for this one, for the type. And I think most of the tables that you've worked with so far kind of make sense. Like a membership holds a membership, contact holds people's names, telephone obviously holds telephone, address, etc. But common lookup is a little different because common lookup is an animal differently. So most of the time when we're designing databases, we try really hard to make sure that a table only holds data for that object. So like if we're putting a contact, we only want contact stuff in there, like a telephone table. If we build a telephone table, we don't want address information in there. We don't want any duplicated data. We want everything very much nicely pieced out so it's organized, right? But what common lookup does is it holds lookup values, because there's a lot of things that's like, okay, like this isn't really like part of this, it's not really part of that, so where does it go? Well, that's what common lookup's for. And if you think about a drop down menu, common lookup is like the king of drop down menus, right? So like, for example, if we have a group, like let's say we have two types of accounts, right? Because right now we're working on system user. Well, let's say we're Redbox. Well, let's say that we have users that are like system admins. You know, they're the actually people that manage Redbox. Like let's say give refunds to people or whatever. Let's say that it's all part of the same system. In this case, like we're a movie renting database, right? So let's say we have two user types. We have system administrators, and then we also have normal people. Common lookup will hold values for both of those. So that way when you create your database, it can be selected in when you create a web application and create their users, it can be selected from a drop-down menu. A good example for this one that eventually we'll use is we actually store the types of credit cards that we take in here. So let's say Visa, MasterCard, Discover Card, right? We put those in our common lookup table so that way they can be referenced. So let's say we put those in there, and then in our web application, we can have let's just see if we have anything in there. We haven't. Okay, good. So we have something in here, right? So let's say that we want to see credit card types, right? Because we keep members' credit cards on file. So let's say that in our drop-down menu on our web application, we can dynamically pull, you know, because when you buy things on Amazon or whatever, you're putting in a credit card, it says, oh, what type of credit card is this? Well, where do those values come from? They come from right here. So we can say select common lookup type. Let's do meaning. From common lookup, where common lookup context is equal to member. Now you'll notice that I pulled a couple other things in here that we would want to adjust our query to filter out, but you'll notice that I have my MasterCard, Visa card, and Discover card. And additionally, like our other scenario, we were talking about membership types. We have a group membership and an individual membership. So these are basically for populating drop-down menus. And we'll talk a lot more about that. But just know that the common lookup is, think about it, I guess, kind of literally. It holds values that we're going to commonly look up, whether that's in a web application or whether that's actually in our database, just tying things to it. So like in the case of System User Lab, when we create system users, We want to tie that to something. Now, as we've talked a lot before, a lot of people are probably thinking, well, why go through all this extra effort to create this whole other table just to hold Visa when we could just, maybe have people type Visa, like what's your credit card type, and let it be Visa. Well, because there's a million different ways to type Visa, right? There's Visa, and you would be blown away at what people do with data, right? So the best thing to do, that's why we have drop-down menus, right? The best thing to do is to make sure that the drop-down menu exists. And then furthermore, like you web developers are thinking, well, I can pre-put that in there. We can just store the text in the database. But the problem with that is that the database is meant to be the final catch-all, do-all. And we want our data to be very integral. And beyond that, there's a lot more we can do once we connect it. So for example, let's say all of a sudden we no longer take Discover Card, right? And your boss says, hey, we don't take Discover Card anymore. We need to take that off the website so people don't think they can put in a Discover Card. Well, if you built it into the web application, you're like, okay, well, I got to go into my HTML and change that. Versus, you're adjusting code, right? Versus if you have it built into the database, maybe you have a management web application that lets you adjust values in your database, which is, most of the time. You could just go in and delete, with a button. A secretary could do it. Or if you're just, let's say you're in the early stage, you don't have a web application to manage, all you have to do is go in here and delete that one row, right? Delete from common lookup, where common lookup meaning, now I'm going to just typo this for a minute, is equal, because I'm not actually going to delete it, is equal to Discover Card or whatever. You type it all out and then boom, it's gone. And on the website, magically, instantly, nobody's using Discover Card. Okay. And what's even better is you could even put start and end dates. So like, let's say that you take Discover Card, or there's a certain date, you could build your database to where there's start and end dates for when it's active, right? So there's a lot of really cool things. So that's why the common lookup table is there. And we'll definitely get more practice with it. So if you don't fully grasp the concept right now, just know that it'll come around, but just know that it's tied to a bunch of different tables because it's how we're going to hold kind of like values that need lists that are not. It's basically a way to hold possible values in a list. So anyways, I have rambled on for quite some time, and I've given you a few examples of how to change these. So I think we've covered both the topics, covering the lab and how to create the tables. Does anyone have any questions? I know a lot of people are taking off, and I know it's mutual night, which I'm guessing is probably like a big part of this. So does anyone have any questions real quick before I end the recording?
Yes, I have one question.
Okay.
So for this assignment, you want us to submit all of the SQL and text files for the lab?
Yes.
Okay. Would it be easier to have them in a zip folder?
It's up to you. Honestly, it's kind of I'm not going to say a pain. Let's put it this way. When you submit a zip folder, I have to download the zip, unzip it, and then open the files versus if you just upload them individually, like I don't even have to leave the web browser. I'm okay to do either or. So whatever's easiest for you guys, feel free to do it.
Okay, and then you just want the underscore lab because when we run the apply Oracle, it'll also create the non-lab counterparts.
Correct. So yeah, you can upload them individually, or if you are going to zip it, like you can just zip your whole Lab2 directory. So I guess I'll show you. If you want to do the zip, you can actually just right-click the folder, go to compress. Here is a zip, and boom, there's your Lab2. You can just upload that whole thing.
Okay.
And I guess on that topic, if you ever need help troubleshooting something and it's later on, right now we're pretty basic. Eventually, at some point, if you get stuck, a lot of times, like when we get into lab like 8, 9, the labs are really built on each other. So there may be times where like a small little mistake, like maybe you're just missing a dash in a word in lab 6, it won't manifest until lab 9. And so in later labs, I'll actually have you send me those zip archives, because then I can actually just load them up in my virtual machine and run them. So just as an FYI, if I ever ask you to send me the zip, that's how you do it. You can actually I'll have you zip your whole data folder. So if you go into home data and the CIT225, I'll just have you zip this whole thing and send it to me. So okay. Good question.
I do have a question.
Okay.
Do you mind to open the apply Oracle Lab SQL file, please?
Sure.
So I'm done with the lab for the week, and I went with the tutor for him to check, and he said that everything's good. There's no error or anything. However, in this part where it says like just where and the table in the second part, sorry.
All right.
That's right. All the names for me, instead of shows underline lab, it says underline SL. But there is no error or anything in my
he's talking about the sequences, which was the next block.
Oh, gotcha. So if I go, so if you go on the website, like if something's not working, there's this confirmation for tables, and then there's this confirmation for sequences.
So and that's the point. Like just the whole thing's right, and the tutor said that's right. However, when I open my apply Oracle SQL file, it does not show lab underline S1 or SL, just member underline SL. Does that make sense?
Yeah. So if you go to the instructions on the website, you can take and copy this, because we copied. If I'm guessing, because like I did, I copied the file from the lib folder, which means that it was built to do like the system user, not system user lab stuff. And so if you come in here to this website, step 12 is the confirmation for sequences. You can just take and replace the query that's currently there with the one on the website.
Okay, so if I do that and I run, should be fine, right?
Yep, and then it should look exactly like it should. So.
And then I save it?
Yep.
Or that's just for tests?
You can save it. And so basically these validation queries, we like you to have them in your scripts, because that way when we're grading it, the difference for us is we can see like in 2 seconds whether it's all good, because those scripts these queries were basically made to show us all the things that were done in the lab. So that way we can look at it and identify errors, and really they're for you. So you can look and say, okay, yep, this matches what's on the website, right? So that way, but like, let's say rental items missing. Well, then you know, oh, something's wrong with rental item. I need to go look into that and see what's wrong. Because the idea is that if everything shows up here, odds are you did the labs correctly.
Oh, okay. And there is 2 confirmation tables. Does not matter which one I copy.
You'll want both of them. So there's the one for the tables, and then there's the one for the sequences.
And both I put in the same document.
Yep.
Okay.
Yep. So then at the end, like in your terminal, after you run it, you should get 2 boxes, one on top of each other. One is for the tables, and then the other one's for the sequences.
And like just the other one, do I put it below of the spool off or after that?
You'll want to put it before.
Okay. Sounds good.
Yep. Because yeah, now that I have those two in there, like here's my output. The first one is my table, and I've only done the one. So I have my system user lab, and then further down my sequence. Now,
And the way that I run to check if that's correct, I just call the file apply Oracle Lab2, right?
Yep.
Okay. Thank you.
Yeah, no problem. I'm actually going to uncomment those so I can see more than just the two that we did. Did I not say that? Anyways. So yeah, good question. I think that's any other questions, I guess.
I think we pretty much covered everything.
Yeah, we really went in depth. So
yeah, the only thing that didn't match with the instructions was the common lookup, like the altering of the system user lab. If you run that and then have the displayed results, they don't match up at all.
okay, yeah, I'll take a look at that
with the instructions.
Yeah, I'll take a look.
I figured that out. I think you have to run it after you run the apply Oracle Lab 2, and then it printed off normal.
Yeah.
Okay. Yeah, I'll take a look though.
All right.
Oh, and that's why that's not working. All right. Well, if there's no other questions, then I guess we will call it. We'll just say good luck, and hopefully it works for everybody. Once you get the hang of it, it's not too bad. So, as you guys that are around probably already know, because it sounds like a lot of you guys have already been working on it. So, anyways, good luck this week. If you have any questions, feel free to shoot me a message in Slack, and good luck.
All right. Thank you.
Yep. Thank you.